Good evening to my dear students. Today we will see Engineering Mechanics lecture series part 3. In the previous lecture we have seen how to determine the resultant of a force using parallelogram law of forces. Now we will apply the parallelogram law of forces to determine the resultant. Let me start with the problem. Two concurrent forces are acting at an angle of 30 degrees. The resultant of the two forces has a magnitude of 15 Newton and the value of one force is 10 Newton. Determine the magnitude of the other force. This is the problem. So the problem will be given in the description. You can refer it. Now going to this problem. So in this problem they have given the resultant of two forces is having a magnitude of 15 Newton. One of the force is having a magnitude of 10 Newton. The angle between the two forces it's 30 degrees. You have to find the magnitude of the other force Q. So let me take that R is equal to 15, P is equal to 10 and theta equal to 30 degrees. So the problem is now represented here in this particular diagram. So the P force is acting like this, the Q is inclined at an angle of 30 degrees. Now the resultant is acting here. Now you have to determine the magnitude of the force Q. Now using the parallelogram law, the equation to find the resultant is R is equal to square root of P square plus Q square plus 2PQ cos theta. So now I am squaring on both the sides. So R square equal to P square plus Q square plus 2PQ cos theta. We know the magnitude of R, we know the magnitude of P. We will substitute in this equation. So we will get 15 square equal to 10 square plus Q square plus 2 into 10 into Q cos 30. Now solving this, we can find the value of Q. The magnitude of Q comes to be 5.48 Newton. Now we will move to a next problem. So let me explain the problem. Two concurrent forces are acting at an angle of 60 degrees. The magnitude of one force is 12 Newton and the magnitude of the other force is 18 Newton. You have to determine the magnitude of the resultant as well as the direction of the resultant. So let me assume that P is equal to 12 Newton, that is magnitude of the first force. Q is equal to 18 Newton, that is the magnitude of the second force. Theta equal to 60 degrees. Now this is represented here in the diagram. So P and Q are the two forces acting at an angle of 60 degrees. You have to find the magnitude of the resultant and the direction alpha. Now using the parallelogram law equation, R is equal to square root of P square plus Q square plus 2PQ cos theta. Now you substitute the value of P and Q in this equation. So P is 12, Q is 18. So 12 square plus 18 square plus 2 into 12 into 18 into cos 60. Now solving this, we get the magnitude of the resultant force as 26.15 Newton. Now to find the direction of the resultant, alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. Now again you substitute the values of P, Q and theta here. So tan inverse of 18 sin 60 divided by 12 plus 18 cos 60. Now you find the value within this bracket and take tan inverse. We get the value of alpha as 36.34 degrees. So now the resultant is having a magnitude of 26.15 Newton acting at an angle of 36.34 degrees. So now this is going to be the resultant. Its magnitude is 26.15 Newton and alpha it is equal to 36.34 degrees. So in the previous topic we have seen how to find the resultant of two forces using parallelogram law of forces. Suppose if there are more than two forces acting on a particle, then in order to find the resultant force, we use the principle called as resolution of force into its components. So this resolution of a force into its components helps us to determine the magnitude of the resultant as well as the direction if there are more than two forces acting on a particle. So now first we will see what you mean by resolution of a force into its components. It is nothing but splitting up of a force into components along a fixed reference axis is called as resolution of a force into components. What do you mean by that? Now, suppose a force F is acting at an angle theta with respect to the horizontal axis. Now, this force can be split into two components along its x and y axis, which are called as reference axis. So now when you split that force into two components, it can be represented as along the horizontal or x axis, it can be represented as f cos theta. Along the vertical axis, it can be represented as f sin theta. Here the direction of the force is also important. So whether it acts towards the right or left, whether it acts upwards or downwards, because since force is a vector quantity, it has both magnitude and direction, we have to indicate the force along with its sign convention. Suppose by resolving the force, if it acts along the horizontal axis towards the right, it is positive f cos theta. Similarly, while splitting the force, when the force acts upwards in the vertical axis, that is y axis, it is positive, so it is called as f sin theta. Now you go to this particular case. Now if you resolve this force into two components, f cos theta, f sin theta, but in the horizontal direction the force acts towards the left, and in the vertical direction the force acts downwards. So in such case, this f cos theta will be minus f cos theta. Similarly, f sin theta will be minus f sin theta. So indicating the force along with the sign convention is absolutely essential. So now we are going to see when the force is applied along all the four quadrants, how the force can be split into its components. Let me first see the first quadrant. The force is acting outwards. It makes an angle of theta with the x-axis. Now if you split this force into two components, it will be f cos theta acting towards the right, f sin theta acting vertically upwards. So towards the right is positive and towards upward is positive. So both sign conventions are positive in the first quadrant. So this case is valid only when the force is acting outwards. Second, if you apply the same force in the second quadrant, again it makes an angle of theta. Now if you resolve this force into its components, so in the horizontal axis or x-axis it will be f cos theta, and the vertical axis it will be f sin theta, but here it is acting towards the left, so it is minus f cos theta, but again it acts upwards, so it is f sin theta. This is about second quadrant. Now going to the third quadrant, the same force f acts outwards. Now if you resolve this into two components, it will be minus f cos theta since it will be acting towards left, whereas minus f sin theta since it acts vertically downwards. The same force, if it is acting in the fourth quadrant, which makes an angle of theta with the x-axis. Now if you resolve this force into two components, it will be f cos theta in the positive and minus f sin theta in the negative. So when the force is acting outwards and if it is represented in all the four quadrants, this will be the resolution of the force into its various components along the four quadrants along with the sign convention. The same can be tried if the force instead of acting outwards, if it is acting inwards, what will happen? That can be tried as a assignment or practice for you to understand the sign convention while splitting up of the force into its two components. So here the important point you should remember is when you split a force into two components, along the x-axis it should be f cos theta, along the y-axis it should be f sin theta, and along with the positive or negative sign it should be indicated. How to find the resultant of more than two concurrent forces? Already we have seen how to resolve a force into two components. Now we know that how to resolve a force into two components along its x and y axis. Now using that principle, now we will find the resultant of more than two concurrent forces. What should be the first step? So after splitting up of all the forces into its two components, the first step is you have to determine the sum of all horizontal components. You have to determine the sum of all horizontal components, and that is sigma fx. The second step is you have to determine the sum of all vertical components, that is sigma fy. So while determining sigma fx and sigma fy, we should be very careful to include the sign convention. Whether the force that is split into x or y component, it is acting in the positive x direction or in the negative x direction, or positive y direction or negative y direction. Accordingly, you have to put the sign, and then you have to find the sigma fx and sigma fy. After determining sigma fx and sigma fy, then the magnitude of the resultant is found using the equation r is equal to square root of sigma fx square plus sigma fy square. So this equation gives the magnitude of the resultant. Then the direction of the resultant is found using the formula alpha is equal to tan inverse of sigma fy by fx. So by using this procedure, you can determine the resultant of more than two concurrent forces acting on a body or particle. So we have seen in this lecture how to determine the resultant of two forces using parallelogram law. Then we have seen how to resolve a force into its component along x and y directions. Then we have also seen the procedure that should be adopted to determine the resultant of more than two concurrent forces acting on a particle. So this comes to end of this part of the lecture. We will see more number of topics in the further lectures. For more interesting lectures, please do subscribe and share it. Thank you.